So let's go to the next topic. We have the principle of hydrostatics. So we have the definition. So let's start with the pressure. No? It is the force per unit area exerted by a liquid on a gas, or a gas on a body or surface. So with the force acting at the right angle to the surface uniformly in all directions. We have the equation for your pressure, that will be P, so that is the symbol. So that is force divided by your area, or say this is can be F over A. So usually in SI the unit is pound force per square feet, or it can be also pound force per square inch, while this is this is already in, this is English, sorry class, this is English. Now for SI units we have Newton per square meter. Okay. Pascal's law, developed by the French mathematician Blaise Pascal, states that pressure on a fluid is equal in all directions, in all parts of the container. Now I have here a container. No? So this is a container class. Container. So in the container, nalagyan ko siya ng tubig. So what will be the level of tubig ng bawat each portion? So the same level din ba siya, or at different sizes mag-iiba-iba ang level niya? So if we're going to pour a water on this container, so what will be the level of water? Pag ito naka-slant, mababa ba siya? Somewhere here. Pag ito naka-ganito, somewhere here. Or pag ito ganito, somewhere here, the level of water, or somewhere here. Okay? So what will be the level of water? So Blaise Pascal, that is in every we call it states that the pressure on a fluid is equal in all directions in all parts. So we have, if we're going to pour it with the water here, now if I have this fluid, I pour it in this type of container. So usually magiging ganito ang itsura ng level of fluid natin. So they have the same level disregarding the shape and size ng ng container. And also in every position, in every level, so they have the same pressure. So for example here, at point A, point B, point C, at point D. So ensuring they have the same height, so the pressure acting at A is equal to the pressure acting at B, the same also pressure acting at C, and the same pressure also acting at D. So they have the equal pressure acting on the same level. Take note of that class. So that is the Blaise Pascal's of the Pascal's law. We have the description, gauge pressure. Let's say that is the relative pressure. So described as the pressure above or below the atmospheric pressure, and it can be measured by a pressure gauge or manometers. Now, for the small pressure differences, a U-tube manometer is used. So it consists of a U-shaped tube with one end connected to the container and the other open to the atmosphere. So this is only used for small pressure differences. So I have here the sample images of U-tube manometer. So you will notice, class, kaya tinawag siya ng U-tube is that literally it has a shape of U. So yeah, you have a shape of U, and the fluid is coming towards here. So usually yung fluid natin or air or fluid is passing through here and pushing this one. So the basic operation ng YouTube manometer, so yung fluid flows dito. Now, as you apply the fluid flows, so you exerted pressure here dito sa tube na ito. Then there is a corresponding other, call this other liquid dito. Sometimes it is can be an oil, mercury, or mostly that is mercury on oil. So with with the fluid running here, so the pressure is pushing the other fluid dito. So that's why it gives reading kung how much pressure yung i-exert ng fluid dito. So there is a label here showing kung ilang with the corresponding number to indicate how much pressure is being exerted by the fluid flowing to this section. So may bypass dyan na T to show yung to push the other fluid. So usually yung oil and mercury does not mix with the other fluid. So that's why maliban na kung oil din and mercury ang ginamit mo. But if you're using H2O, it will not mix, and also the mercury, it will not mix. So this is only used for a small small pressure differences. Pero pag gumamit ka ng mga high pressure pipe, high pressures, so let's say water distribution system of a building or water distribution of the katulad ng water district, so we're not using the manometer. So usually kung itong gagamitin mo pa rin, it will, pag ikakabit mo siya sa system, mo malaking tubo, it will be burst out. So sobrang lakas ng pressure, magra-rupture na yung glass. Okay? So this is only for small pressure difference sa mga usually that is can be used for ducting, yung to read the pressure. So when you see ducting, nagkaroon ng ducting. So ito yung nakikita nyo yung sa mall, no class? Yung sa mall, we have this silver, o yung tinatawag na silver color, or sometimes they call it the GI duct. So yun yung nakikita nyo. So ina-attach ito siya sa ducting. So I will attach a picture para to mas madali natin maintindihan what is yung. Okay, so ito yung tinatawag na GI ducting class. So ito pwede natin siya i-incorporate or pwede natin ito ikabit natin doon. Just to distinguish how much is pressure or yung pressure na ini-exert ng hangin. So mostly it's not mercury they're using. Sometimes ang YouTube sa ganito they using rather than using a mercury or oil, so because oil is heavy. So in terms of density, mercury and oil are heavy. Now, mostly ginagamit is yung fluid is H2O or water. So usually kung kakabit mo dito is oil or mercury, hindi siya gagalaw yung YouTube mo, YouTube manometer mo. But if you're going to use an H2O, so then you will observe a movement of water here. You will observe the moment of the pressure level of H2O. So once you observe that one, so that is the time you do reading, and kung walang gauges ito, you have to compute. So we can later on we'll do computation how much pressure is being exerted by the level or height ng bawat YouTube manometer. But in actual class, so it can be applied on this type of ducting. But for mga high pressure pipes tulad ng ganito class, no, so makikita nyo this is for sometimes used in a water distribution system. So we cannot use yung YouTube manometer dito because yun na nga ang basic explanation, mas masisira yung YouTube manometer mo, masisira ng YouTube manometer mo in order to read. You know, also this was mga gas piping, so we cannot use that one. So, ang ginagamit that is mostly used for this type of application is yung pressure gauge. So, ito yung class yung pressure gauges. So, mapapansin nyo, there is a dial, no? So, makikita nyo yung unit. So, that is a unit, that is bar. So, that is the unit of pressure, bar, kPa, PSI. So, you have parang katulad din siya ng parang orasan. It has a dial indicator. Now, this goes, makikita nyo that is bar sa loob yan. That is 1 bar, 2 bar, 3 bar, till 7. Then, you have the times 100 kPa. So, that is the unit for Pascal. So, that is Newton per square meter then. So, we have here an indication how much is the Pascal, and we have also the outside here. Makita nyo PSI. So, that is 20, 40, 60, 80, and 100 PSI. So, that is the unit. Now, pag kinabit mo siya sa piping, usually, this one, so, for example, this one, yan. Then, I will install it sa piping. So, I have here, so, ikakabit mo, that is threaded, so, you will be putting it in a nipple. Then, you have the fluid flowing here for a high pressure pipe. So, this pressure, high pressure pipes flowing toward here, the fluid here of your sample, that the pipe is conveying an H2O. So, high pressure pipe, so it will push the pressure here. Now, as you increases the pressure, so the same also yung reading ng dial. So, tumataas yan sa something here. So, depending on the type of pressure that is being applied to the system. So, umakyat siya. So, let's start to, what is, usually this is a tinatawag na Bourdon tube. Now, yung itsura ng what's inside behind yung Bourdon tube. So, ito yung itsura niya. Okay? So, we have this one. So, if you're going to dissect yung sa likod niya, ito yung magiging itsura niya. Then, the pressure is flowing toward here, or the fluid is flowing toward here, and it gives the action, mechanical action to provide the swinging of the dial. Doon sa kabila. As you increases the pressure, so it pushes here, and it triggers the coil here, and to provide you the dial movement ng gauges to show you what will be the value ng reading ninyo with the corresponding that one. Now, next we're going to discuss yung atmospheric pressure. So that will be the pressure at any point on Earth's surface. So from the weight of the air above it. Okay? So usually if we are in the Earth's surface, so usually this is the Earth's surface, and ikaw nandito. Now, what we are experiencing, so what are the atmosphere, or yung what is above on us, is we are being exerted by a pressure. So, our body is being acted by a equal pressure. So, yun ang tinatawag ng atmospheric pressure. And the unit, the pressure that is acting in our skin, so sa balat natin, the pressure that is acting on our skin ay yung the value that will be the 14.7 psi, or it can be 700 or equal to 700 mm of Hg, and that is 101.325 kPa. So that is the pressure acting in the human skin. So what we're experiencing now in the Earth's surface. Pero pag if you are submerged below the sea level, so usually so mapapansin nyo, as you go, this is the ground, you have here the ground, and this is the sea level you have. Then ikaw naglangoy ka doon. So the pressure now is acting in you is the total pressure is acting in the surface, or yung lalim ng, how much lalim ng as you go deeper. So the pressure is acting in your skin, that will be the total pressure, that will be the atmospheric pressure, no? plus the hydrostatic pressure. So that will be yung pressure ng due to elevation and gravity, that will be density, shall be that with the density, gravity times the height. So later on, discuss or elaborate that one. So, pwede imagine, as you go deeper, mapapansin nyo, as you go deeper, the higher or the, what do you call it? Tumataas yung pressure as you go deeper. So, the pressure that is being exerted in your screen increases as you go deeper and deeper. So, that's why, ang minsan naging problema dito, katulad yung mga sea divers, no? So, yung kasi, tago ang delikado pag nagda-dive ka. So, as you go deeper, so yung muscles natin sa skin are our muscle is being compressed. So, usually hindi mo mapapansin yan, but it's being compressed. So, once it is compressed, so yung muscles natin are being compressed. And also, the same time, since it is an equal pressure, the same also yung mga veins natin are being acted by pressure. So, being acted by pressure. So, the same also, pag delikado, yun, that's why yung mga diver, as they descend, and pag descend and paakyat na sila, they do staging. So, when we say staging, so, kung, to describe that one, so, if you have here the sea level, no? If this is the land, okay, so, usually they do staging. So, let's say here, for certain, let's say 20 minutes, then, dito na naman siya another 20 minutes in this level. So, hindi siya directly umaakyat. So, why? Bakit? So, because of the hydrostatic pressure. So, yun ang explanation that is our skin is being compressed. So, once you're, di mo nararamdaman yun kasi gradually lang naman yun, di biglaan. So, it's being compressed unti-unti. So, the same also yung, natin, yung veins natin, yung ugat are being compressed. Our veins are being compressed by pressure. Being compressed by pressure. Now, if you're going to bigla kang aakyat doon directly doon sa surface, so, usually, ang mangyayari is, we have bigla na lang release of pressure. So, once we release the pressure, the same also biglang magbo-bloated yung mga veins mo. Then, there is a possibility na mag-rupture yung mga veins. So, what is the rupture? So, usually nangyari, nagiging hirap is, nangyayari is pag nagbiglang ganon is nagkakaroon ng pumuputok yung ugat. So, once na naputok ang panugat, so that is katumbas na kagad ng stroke na kagad. So, that's why yung nagiging nangyayari na minsan sa mga divers na they're using air compressor that is yung not an oxygen tank. Yun yung nangyayari, alam ba, namatay yung compressor. So, if you are meron kang for example, this is your seawater, then nandito yung boat, okay? Tapos nandito yung compressor, no? So, yung usually gamit lang naman lang hose, okay? Tapos nandito siya sa ilalim, nagda-drive kung ano ginagawa. Tapos higop-higop niya yung compressor, yung hangin na galing from the compressor. Now, ang isang delikado dito, pag halimbawa kaya nagkakaroon ng aksidente, also pinapagbawal na ng yung using the compressor is pag namatay yung compressor, not only just because of it affect your yung lungs mo, and also pag halimbawa, for example, nagkaroon ng problema yung compressor, so usually ang nangyayari ng tao doon sa ilalim pag wala na supply ng hangin, you do panic. So once you panic, so yung katawan mo maghanap talaga ng hangin, then eventually you want to grasp more air. So that's why nag-immediate ka mag-akit dun sa taas. So once na umakyat ka without yung decompression ng staging by level, so nagkakaroon ng ng biglang release of pressure dun sa sa veins mo in your skin. So that's why nagkakaroon ng na-disgrasya, pumuputok yung mga ugat because of the sudden release ng pressure dun sa mga skin nila. And yun, sudden flow of of liquid to your veins, so that's why it do rupture. Then yun na, katubas, you gain your stroke. So, yung iba na-stroke because of using the compressor. Okay, so that is the yung tragic na nangyayari, and also that is also one of the devastating effect without decompression when you are into diving. Right. Next we discuss the vacuum. So it is a space that has all matter removed from it, and it is impossible to create a perfect vacuum in a laboratory, but you can create a vacuum, but not perfect at one, no matter how advanced the vacuum system. So some molecules were always present in the vacuum. One explanation ng vacuum being vacuum is yung you will notice that is the extraction of, for example, yung we call it application ng mga ano natin ngayon, industrial use using the vacuum is to remove the molecules, trying to move the molecules. So we're trying to move we're extracting the air doon sa space na yun in order to sometimes they use it for preservatives. So once there is no air, the activity of the bacteria is less, so they cannot reproduce ng mabilis. So ito yung example ng vacuum that ginagamit ngayon in industry. They do vacuum to remove yung molecules from the space. For example, we have here the preservation of food, like ng isda, mga daing. So they do vacuum sometimes with the meat for preservation. So mapapansin nyo, that is extracting so cellophane, then extracting the air molecules. So nandun yung we call this product. So extract ng molecules from there or air para magal yung activity ng bacteria. But there is still bacteria inside, but the activity will be lessened. So the reproduction of the multiplication of their species will be lessened. So the longer the preservation ng food. So that is on the images of yung product natin. That is in terms of a vacuum. Now we have discussed next is the absolute pressure. So described as the pressure above the absolute zero, or that is have vacuum. Absolute zero, that will be vacuum. So we have the equation for the absolute pressure, that will be equal to P gauge. So this is the gauge pressure that you obtain from instrument, then plus your pressure at the atmosphere. So that is the absolute pressure. So if you already finish your thermodynamics, and also this is being discussed in the P6, so this is a form of review, but it will be needed na natin palagi natin gagamitin, especially where we're dealing with absolute gauges in terms of piping. Now, variation in pressure. For example, we have here a bar submerged in a fluid. Now consider any 2 points that will be 1 and 2. So 2 points 1 and 2, whose difference in elevation is h. We have the elevation between 1 and 2, that will be h. Now this is expressed in angle. We have formed here an angle theta. Then we have the length, and we have the length represented by L. So that is represented by L. So this is now the length of the bar, where the bar or this have a cross-sectional area. So let's put it here, your A, as the area of the bar. And we have an reacting force on this level. So magkaiba ang force that acting on this level, since it is a different in elevation that we have. And also below here you have also a force, a reaction. So this will be the force 1 and this will be the force 2. And we have the center of the gravity, which is acted by the weight of the object. Considering this is assuming this is the center of the gravity, so we have your weight here acting. and it is an angle perpendicular to the bar. So we have your theta here acting, indicating. So assuming that we going to rotate the axis of our representation, the axis, so we plot the axis here. So this will become your x-axis and this will be your y-axis. Now we can compute yung value ng h natin. So we have your length here. So this is the hypotenuse. Then what I have here, hypotenuse, and I have your theta here. Then I have your opposite here. So we can write the equation. So we can write that is so. So ito kasi madalas kong ginagamit, which is an sine so. That will be sine of theta. This means opposite. What is your opposite? That will be your hypotenuse. The opposite, that is your h. The hypotenuse, that will be your L. So if I'm looking for the h, so I can derive your equation as sine theta, which is times your length. So that is the value of your h here to get the height value. So usually SOHCAHTOA, they call it SOHCAHTOA. So that is in cosine, adjacent, times hypotenuse. Then you have your TOA, that will be tangent, opposite, and adjacent naman siya. And we have different pressure acting on this point, and we have your P2 and we have your P1. Now with reference to the figure, we can solve the weight of the object. So by means, we have the equation which is yung weight. Usually this is can be expressed as usually that is mass times the gravity, no? Or we can also express it by weight, that will be specific weight times the volume. Now since our specific weight, since our volume can be expressed as area, we have your A here. Then multiply it by length to get the volume. Then we can compute by means of the reaction forces. So that will be summation of forces. So summation of forces along the x-axis, that will be, so since it is static, so we'll be putting it here 0. Summation of forces along x, so there is no movement, is equal to 0. Then we have the value for the force 2 minus your force 1. Now is equal to the weight. So the weight is in terms of on the x-axis, that will be, so projecting the angle here, no class, so we'll be forming a right triangle. Now what we need is in this part, so that the opposite, so we have here the opposite values is the force. We are looking for the reference on x, so this will be the opposite. So that will be, so you have the value of hypotenuse, then your opposite. To get the value of the opposite, so kailangan natin yung opposite. So the value of your opposite here, that will be so the value of opposite here is that will be sine of theta, that is equal to opposite, that will be your O. Then you have your W. To get the value of your O, since we need the horizontal force acting on the X, so we have sine of theta times your W, or the weight. So we can equate that one here in our equation. So that is the force acting on this side. Okay. Then we have W, or the weight, then multiplied by the sine of theta. Now we can express our forces, since we all know that pressure is equal to force over area, and in terms of area, we can rewrite our equation that will be area so we're looking for the force, sorry, this one, change this one. So in terms, we're looking for the force acting, so we have here your force that will be equal to the pressure times your area. Now for the value of your F1, so that will be pressure 1 times yung area natin, since we have the common object, so they have the equal area. Now, ang pinagkaiba na lang, we don't have the same pressure and we don't have the same force, so yun ang pinagkaiba. Then we have your F2, that will be your P2 times your area, since your area is the same. Then we can substitute that in your equation here. So we have now pressure 2 times your area minus pressure 1 times your area, which is equal to your weight, with the value of weight is the specific weight times the area times the length times the sine of theta. But our sine of theta, or yung L sine of theta, is equal to your H, so we can factor that one as, or cancel out, which is yung common. So cancel natin ito, so we have the same value magkabilaan. So our pressure na P2 minus your P1 is equal to the specific weight. This is L sine of theta, so this will become now your value of H. So we have the equation now. Since ang specific weight natin is equal to weight over the volume, where your weight can be expressed as the mass times the gravity over the volume, and we can express this one as density times the gravity. Now we can rewrite the equation of pressure difference between P21 and P2, so that will be density times the gravity times the height. Okay, so that is this is another variant of the equation. So this is the variant, another variant. So we can expand it by applying them. For example, if density and gravity is being given, so you can use this one to get the change in pressure. And also we can rewrite that the pressure at point 2, that will be the pressure of point 1 plus the density times the gravity times the height. So this means that any change in pressure at point 1 would cause an equal change at point 2. Therefore, the pressure applied at any point in a liquid at rest is transmitted equally and undiminished to every other point in the liquid. So assuming that at point 1 in the figure, so lies on the free surface. So for example, this one, yung P1 mo nandito P1 mo, or where transport, nilipat mo dito sa the free surface. So yung P1 mo lies on the free surface. Now your P1 becomes 0. So that will be the reading in the pressure gauge, and our equation will become, since it is 0, that will be pressure that will be equal now to the density, gravity, and height. Now, yung sinasabi ko, so assuming that at point 1, so this is now your point 1 lying on the free surface. So, this is the, illustration to show you if the point 1 is on the surface, so we have the equation. So ganito magiging representation yun. And this will be the equation if the point 1 is lying on the free surface. Now, we consider that the points 1 and 2 lie on the same elevation such that the height is 0, this one. No, if the height is 0, then the piece of 1, pressure 1, so this one is already lying on this, dito na siya sa surface na ito. Okay? So, ibig sabihin, umangat na siya doon. So, they have the same level, lie on the same elevation such that the height is 0. Then, the pressure 1 is now equal to pressure 2. Now we have here pressure below layers of different liquids. So you will notice here we have a container, then we have the liquid 1, 2, and 3. So they are different types of liquid. So different densities of liquid. Now they do not mix on each other, so we said because of different type of liquid. Now consider now with the bottom we have the pressure on the bottom, so we have also the gauge pressure, or here we have your air sa itaas. Now to get the pressure at the bottom, we have the equation pressure at the bottom. Okay. So that will be equal to the summation of specific weight, then times the height plus the pressure plus P, or let's say the pressure sa ibabaw. Or we can expand that one, the specific weight ng liquid 1, then we have the height ng liquid 1 plus the specific weight ng liquid 2 plus the height of liquid 2 plus the specific weight of liquid 3, and you have the height of 3. Then plus the pressure of air above the liquid 1. So that will be the total pressure acting on the bottom of the container. Now we have the pressure head. It is the height H of a column of a homogeneous liquid of a unit weight that will produce an intensity of pressure. So we have the equation for the pressure head, that will be your H. So that is derived from the kanilang equation. So that will be your pressure divided by the specific weight. Okay. The manometer usually bent in a form of U containing a liquid of non-specific gravity, the surface of which moves proportionally to the changes of pressure, and it is used to measure pressure. So we have types of manometer. We have three types now. So we have one, we have open type, has an atmospheric surface in one leg that is capable of measuring the gauge pressure, that is open to the atmosphere. This one is open to the atmosphere. It is being exposed to atmosphere. So exposed to atmosphere. Okay. So that is open type manometer. Then we have the next type of manometer. We have the differential type. So without an atmospheric surface that is being exposed. So capable of measuring only differences of pressures of two pipes or two ducts. So we have the arrangement here. So mostly ganito ang nagiging itsura niya. Lastly, we have the piezometer. So this is the simplest form of open manometer, and it is a U-tube tapped into a wall of a container or a conduit for the purpose of measuring a pressure. The fluid in the container or conduit rises in this tube to form a free surface. So usually the image of a U-tube piezometer is basically if you have the pipe here, and also it's only tapped dito. So, kung ito yung pipe mo, so you have here the YouTube. YouTube. The tube, and it is also open to the atmosphere, exposed to atmosphere. So usually, if you have the fluid running here, so I'm going to put the fluid here, show you. Now, usually the reading here or different fluid acting here. So we have to indicate yung pressure niya. So ganyan yung itsura ng isometer. So you have here, this is the tube. The tube that we use the tube inserted on the pipe. So this is the pipe. So then, now for the sample problem, we have if a depth of a liquid of 1 meter causes a pressure of 7 kPa, what is the specific gravity of the liquid? So for the solution, for the solution, I made an illustration here, so to properly visualize what is happening. Now we have the depth of 1 meter here, class. So we have a depth of 1 meter. Okay. Then the pressure given, so we have given values here. So we have a given value, which is yung height mo is 1 meter. Then you have the pressure of 7 kPa, or let's say this is this equal to 7,000 Newton per square meter, no? Then we have the unknown here, Hg. So what is the specific gravity of the fluid? So what is the specific gravity of the fluid? Okay, so we have the equation for pressure. So that will be specific weight times the height, or this can be expressed as your we call this pwede naman density, gravity times the height, no? So we have the density times the gravity. So expressing it in the solution, so we can get the values. That is substitute natin yung value, which is yung pressure, that will be 7,000 Newton per square meter. That is equal to density. So we don't know what is the density of the fluid, so density of the fluid is unknown. So the gravity that will be given, that is always 9.81 meter per second squared. Then we have the height of 1 meter that is given to the problem. Now the density of the fluid is equal now to, so we have the density of the fluid, which is 713.56. So the unit will be kilogram per cubic meter. Okay. So you transfer that one, expressing that one. Now for the specific gravity Hg of the fluid, so usually we have the equation. So we have the equation for the density of the fluid, specific gravity of the fluid. So this is equal to this is equal to density of the fluid divided the density of the water. So we have the density of the fluid, which is 713.56, that is kilogram per cubic meter. Then yung density na water, so take note that will be always, palagi sa problem, it will be 1,000 kilogram per cubic meter. Now cancel out yung common units natin, that will be 0 out. So we have now the specific gravity of the fluid is equal to 0.713.56. Sorry. So 713 specific gravity of the fluid. So that concludes our answer in this problem. Okay, this is now your answer. So the specific gravity of the fluids is 0.713. Or let's say it can be 0. Since it can be round up 7114. Okay. So answer. Now to properly illustrate the problem, so we have here the container, no? So we have the reading, which is pressures to that is, the pressure gauge is 6 meter. So here we have the 6 meter on pressure gauge. Una, we have the pressure gauge which is 6 meter, and the tank contains a liquid reads 90 kPa. So this one at point 1, that will be 90 kPa, and the other gauge height, that will be 4 meter, reads 103. So ito yun ang point 2. So we have P sub 1, we have the given that our P sub 1 is 90 kPa, and P sub 2, that is 103 kPa. Now, determine the specific weight of the liquid. So, we can write our solution as P sub 2 minus yung kanina is equal to the specific weight times the height, where the value of your P sub 2, that will be 103 kPa minus 90 kPa, then it is equal to the specific weight, which is unknown. Then you have the height, which is the difference between 1 and 2. So we have 2 meters. So solve it by transposition, cancel out the common units. Now we have the specific weight now is, and using your calculator, we have the value of 6.5 kilonewton. So let's try to expand the equation here. So using your calculator, so we have here, this is 13 kPa, then this equal to specific weight divided by 2 meters. So I'm going to show you now. So let's expand the kPa. So this will be 13 kilonewton per square meter, then divided by 2 meters. So that will be the specific weight. Then cancel out. So this is cancel na, kakancel na yan. So mabawasan na yan. Ay, sorry, not to cancel out. It is the same. Sorry. So we cancel out. So we have 13 divided by 2. So you have the value of 6.5 kilonewton. So now we have the value of 6.5 kilonewton per cubic meter. So that will be the specific weight natin. So that will be the answer.